All right, so here we are with 59, cruising along through these word problems. And 59, again, is similar to 58, and I really like these problems because they are incorporating what we're learning this chapter, so quadratic equations, with what we learned last chapter, which is systems of equations. So using two or more equations to help us solve for a variable. So these are pretty cool. This is starting to put everything that we're learning together into one kind of comprehensive question. So let's go ahead and dive in. And we have a triangular garden has an area of 65 square feet. Its height is 3 feet more than its base. Find a measure of the base. All right, well, let's go ahead and draw ourselves just a triangle diagram to help us. And we know just the general formula for area of a triangle is half base times height. So here's our base, here's the height. And let's see, we have been given some information, right? We know what the actual area is, so we know that 65 is equal to, well, half. Do we know the base? No, we don't know the base. But we do know something about the height. We know that the height is 3 feet more than the base. So 3 feet more than the base. So the height is whatever the base is plus 3, right? So the height is 3 feet more than its base. So the height is 3 feet more than the base. All right, well, normally, here's the equation, plugging in 65 for the area, which comes right from the word problem. So let's go ahead now, and using the information that we just derived, let's go ahead and take this information now and plug it into the equation where h is, and now and when we do that, we'll only have one variable to work with. So what we have is 65 equals 1/2 base times height, but height is now b plus 3, isn't it? So let's go ahead and try to clean this up a little bit, and we will distribute this b through. So we have 65 equals 1/2, and now b times b is going to give us, well, b squared, isn't it? And then, so b squared, and 1/2, excuse me, b times the 3 is going to give us what? Well, plus 1/2 times 3 is 3/2 b. And looks like we have ourselves a quadratic equation, don't we? The only thing that we want to do is, since we're dealing with a quadratic equation, we want to have all of our terms on one side and set the equation equal to 0. So what we're going to do then is, let's go ahead and move this 65 from the left to the right. So we'll subtract 65 from both sides. And when we do that, now we'll have 1/2 b squared plus 3/2 b minus 65 equals 0. All right, looks good to me. So let's see, we have some fractions here. I don't really like working with fractions. And let's go ahead, and I'm going to go and move this just up here so we have some more room to work with. All right, so we could try to factor this right away, but how about instead of doing that, let's go ahead and clear our fractions so that we don't have to work with them. And we're going to do that by multiplying by the common denominator. And if it helps you, you can go ahead and write each thing with a common denominator just to kind of see. So we're working with a 2 and a 1, so we know that the common denominator here is going to be 2. So let's multiply each term by 2. And so when we do that, these 2's are going to cancel, so we're just going to be left with b squared. Here the 2's are going to cancel, plus 3b. Here we have 1 goes into 1 once, 1 goes into 2 twice, so negative 65 times 2 gives us minus 130. Equals 1 goes into itself once, 1 goes into 2 twice, 0 times 2 is still 0. So now we have b squared plus 3b minus 130 equals 0. These two things, this thing and this thing, before we made all these notations, are equivalent. They say the exact same thing, just one has fractions, one does not. And I think this is probably nicer to work with. All right, let's see. Go through, ask ourselves those two questions. Is there a GCF here? Nope, don't think so. So question number 2, how many terms? 1, 2, 3. 3 terms, we know we're either going to be using the AC method or scissors or trial and error. But because the coefficient of our b squared is 1, we really don't have to use either of those methods. Let's just go ahead and create our empty sets of parentheses. We're working with b's, so let's split that b squared up. And now we want factors of 130 that subtract to give us positive 3. Well, this is kind of a nice number to work with because 10 goes into 130, doesn't it? And it goes in 13 times, right? So we're listing our factors. 10 goes in nicely 13 times. And can we somehow subtract a 10 and a 13 or a 13 and a 10, some combination, to get a positive 3? Yeah, we sure can. If we have a plus 13 and a minus 10, well, 13 minus 10 gives us positive 3. Positive 13 times negative 10 gives us negative 130, so I think we've found our factors. And now that we have our factored form equals 0, let's go ahead and independently set each of these factors equal to 0 and solve. So we have b plus 13 equals 0. We have b minus 10 equals 0. So solving for b now, we'll go ahead and subtract 13, so b equals negative 13. And here we'll add 10, so b equals 10. And b represented what? The base of this triangle. And so we know that when we're dealing with dimensions, we're talking about distance, right? We're measuring the distance between here and here. That's the length of the base. Well, can distance ever be negative? Can you have a negative distance, right? Can you walk a negative 13 feet? No, of course not. You just walk 13 feet or you walk 10 feet. So because we had two answers, right, which you would expect from a quadratic equation, but one was negative 13, and we're dealing with distance, go ahead and drop the negative answer because you can't have a negative distance. That leaves us with only one possible answer, which is the positive answer, and in this case, 10. So find the measure of its base. Well, the base, or b, is 10, and we were working with what? We were working in feet, so 10 feet. All right, and you can actually go ahead and plug that in to check, to make sure your answer is correct, right? If the base is 10 feet, we know that the height is 3 feet more than that. So you could expect, if you want to double check yourself, that 65 equals 1/2 times base, which we just found to be 10, times height, which we now know is 13 because base plus 3, or now 10 plus 3, gives us 13. Well, let's see, 65 equals 1/2 times, well, 10 times 13 is 130. And what is half of 130? 65, isn't it? So 65 equals 65. That's a true statement. So we know that our answers are correct because when we plug back into the formula, we get a true statement. So in this case, the base equals 10 feet.